Hello children, how are you all? Hope you all are doing well. This is VKM. Welcome to VKM Academy. In this video, we will be discussing about an important topic of alkyl halides, that is nucleophilic substitution reactions. We'll be discussing it in this video. It's a very important question also from organic chemistry, okay, in second PUC as well as in class 12 CBSE also. Let's talk about that. So, we are discussing about nucleophilic substitution reactions. Nucleophilic substitution reactions. In a short and simple way only, we will be discussing. These nucleophilic substitution reactions, we call it as SN reactions. S stands for substitution, N stands for nucleophilic. And these SN reactions are of two types. One is SN1, another one is SN2. Like that, we have two types of nucleophilic substitution reactions. One is SN1 and another one is SN2. Let us talk about first type of reaction, that is SN1. SN1 is nothing but unimolecular. One stands for unimolecular and N stands for nucleophilic, S stands for substitution. S stands for substitution. So like that, we can give SN1 full form. SN1 full form is unimolecular nucleophilic substitution. Generally, in this tertiary alkyl halides, 3-degree alkyl halides can undergo this mechanism easily. Can undergo this mechanism. 3-degree alkyl halides can undergo this mechanism. Okay. And moreover, this SN1 reaction can occur in or can occurs in two steps. Can occurs in two steps. Right? And now let us make a look on it. What are those two steps? Here I am taking tertiary alkyl halide CH3, CH3, CH3 and Br. Carbon is connected to 3 carbons and hence it is an example of tertiary alkyl halide. Now we will be using a solvent like H2O. H2O is an example of polar protic solvent. H2O is an example of polar protic solvent. This solvent provides certain amount of energy in the form of solvation enthalpy to break this carbon halogen bond. Now bromine is more electronegative. If you break this bond with the help of polarization, carbon gets positive charge and Br gets negative charge. So Br is actually leaving from the carbon and hence it is a leaving nucleophile. Nucleophilic substitution means we are replacing one nucleophile with another nucleophile. We have to replace the Br minus, that is outgoing nucleophile, and we have to replace that Br with another nucleophile. For that we are doing SN1 mechanism. Carbon with positive charge is called as a carbocation, that is connected to 3 carbons and hence it is said to be 3-degree carbocation. Of course, it is the most stable carbocation because breaking of bonds is involved and hence it is a slow step. And hence it is slow step and as well as rate determining step. As well as a rate determining step. It's a slow step, it can determine the rate. That means the rate is actually depends on the concentration of the alkyl halide. Because based on this only we can determine the rate. Now, it occurs in two steps. Among them, we are aware of it. First step is slow step. Hope that is clear. Now, let us move on to the second step. What will happen? Once carbocation is formed, this carbocation is intermediate. Carbocation is intermediate. Once this intermediate is formed, children, immediately nucleophile can attack. That is step 2. If I consider this as step 1, if I consider this as a step 1, now I am taking step 2. So step 1 is formation of carbocation. Step 2 is attack of nucleophile. CH3, CH3 plus a nucleophile attacks from here. So nucleophile attacks onto the carbon. So we are going to produce with the help of this CH3, CH3, OH. This is called as a tertiary alcohol. This is called as a tertiary alcohol. Here nucleophile is OH minus. This step is fast step. Because once carbocation intermediate is formed, immediately it is being attacked by nucleophile. If it is attacked by nucleophile, then you will get a substitution product. So that indicates this mechanism is actually taking place in how many steps? 2 steps. This mechanism is taking place in 2 steps. So now we got to know that this is undergoing 2 steps. In that, first step is rate determining step. So rate is actually proportional to concentration of alkyl halide, that may be any kind of alkyl halide, and as well as concentration of nucleophile. Alkyl halide actually depends on the concentration of alkyl halide, 1, but it won't depends on the concentration of the nucleophile, because nucleophile attacks onto the carbocation in second step. Second step is a fast step, right? It is not a rate determining step, and hence rate is equal to K into concentration of alkyl halides whole raised to 1. Rate is equal to K into concentration of alkyl halide. That indicates rate is actually depends on concentration of the alkyl halide only. It's a very important question also for PU board examination children. So rate is equal to K into concentration of alkyl halide, and hence it follows first order kinetics. As it is, you write it down the points. It follows first order kinetics. In rate determining step, how many molecules are involved? Only one molecule is involved, and hence it is unimolecular reaction. It is unimolecular reaction, because in rate determining step only one molecule is involved, and hence it is an example of unimolecular reaction. Hope that is clear for you. Now some other points we will be discussing it. H2O is a solvent. We have used polar protic solvent. So SN1 mechanism is favored by polar protic solvents such as water. Water is an example of polar protic solvent, because hydrogen is attached to the most electronegative element. If hydrogen is attached to the most electronegative element such as oxygen and nitrogen, such kind of solvents are said to be polar protic solvents. Hope that is clear. And so mechanism part is done. We got to know rate expression, and it follows first order kinetics, and it is an example of unimolecular reaction, and moreover SN1 mechanism is favored by polar protic solvents also. That also we got to know it. Okay. Now let us talk about reactivity of the alkyl halides. Alkyl halides only can undergo nucleophilic substitution reaction, right? And let us talk about their reactivity. Reactivity of alkyl halides. Among alkyl halides, Ri is greater than, Rbr is greater than, RCl is greater than Rf. Alkyl iodides are more reactive than alkyl bromides, than alkyl chlorides, than alkyl fluorides. If you notice it here, R is nothing but carbon, and it is iodine. Carbon is a smaller size atom, iodine is a larger size atom. So the one we can break the bond easily, that can participate in nucleophilic substitution reactions readily. Carbon iodine bond is not formed effectively due to the size differences. If you observe it here, size differences is large. It is a smaller size atom, it is a larger size atom. Because of the size differences, if you notice it, this bond becomes very weak. So you can break that bond easily. You can break the bond easily. But when it comes to remaining carbon halogen bonds, RF bond is stronger somehow. RF bond is stronger because of the size differences. Size difference is very less, it is stronger, we cannot break that bond easily. In another way, a weak base is always a good leaving group. A weak base is always a good leaving group. So among them, what is the basicity order? Here itself, I minus, that means weak base in the sense basicity order. Strong base is F minus, greater than Cl minus, greater than Br minus, greater than I minus. Then leaving ability. Which one can easily leave? Easily leavable group is I minus, greater than Br minus, greater than Cl minus, greater than F minus. So I minus can go easily. Okay. And it is among the alkyl halides we can take. But there are different types of alkyl halides. Primary is there, secondary is there, tertiary is there. So here SN1 mechanism proceeds through the formation of carbocation intermediate. The alkyl halide, whichever the alkyl halide is going to form stable carbocation intermediate, that is going to be the most reactive one. Right? So what you will write here? Alkyl halide which forms stable carbocation. Stable carbocation can react readily. Stable carbocation can react readily. So whichever alkyl halide you can take it. The alkyl halide, whichever that, okay. So it is more reactive whenever it forms a stable carbocation. Let us say, if you consider CH3, CCH3, CH3, Br. And in a similar way, CH3, CCH3, H, Br. And at the same way, CH3, CH2, Br. And CH3, and I can take CH3, Br. This alkyl halide is tertiary alkyl halide. This alkyl halide is secondary alkyl halide. This alkyl halide is primary, but this alkyl halide is methyl. Isn't it? Right? For suppose if I break this bond, CBr bond, we are going to get plus here. If I am going to break the bond, I am going to get plus here. If I am going to break the bond, I am going to get the plus here. If I am going to break the bond here, plus I am going to get it. Right? So, which is most stable carbocation, children, here? 3-degree carbocation is most stable. And hence we can say that, so step means reactivity of alkyl halide. Which alkyl halide is more reactive? 3-degree alkyl halide greater than 2 degree, greater than 1 degree, greater than methyl. So, 3-degree alkyl halide can undergo SN1 mechanism readily. 3-degree alkyl halide can undergo SN1 mechanism readily compared to secondary, compared to primary, and compared to methyl. Methyl halides are less reactive. Hope you understood the point. Whichever the alkyl halide is going to form stable carbocation, that alkyl halide is going to react more readily. Towards which mechanism? SN1 mechanism. Questions based on this also, they can ask you like, out of these two alkyl halides, which is more reactive and which is less reactive? Such kind of questions can be framed. Hope that is clear for you, everyone. Now, so if I take C6H5, CH2Br, it is going to polarize. We are going to break the bond. It is called benzyl bromide, right? And benzyl bromide, it is going to give the cation C6H5CH2 plus. It's called benzyl carbocation. In a similar way, CH2 double bond CH, CH2Br, it's called allyl bromide. This is called allyl bromide. And then CH2 double bond CH2 plus. It is allyl carbocation. Allyl means carbocation, I am writing it as CC. Okay. Allyl carbocation is also stabilized by ERS. Equivalent resonating structures are present. For this, CH2 double bond CH2 plus. If I polarize the bond in this way, then what you are going to get it? Minus and plus can form a bond. This CH2 acquires positive charge. Double bond becomes single bond and CH2. It is equivalent resonating structure 1. It is equivalent resonating structure 2. This benzyl carbocation is there, no? It is stabilized by resonance. It is stabilized by resonance. It is stabilized by resonance like this CH2 plus. Okay. That positive charge is delocalized throughout the ring. So benzyl carbocation has more number of resonating structures, and hence I can say that benzyl halide is more reactive than allyl halide and more reactive than 3 degree alkyl halide, 2 degree, 1 degree and methyl. All of these are examples of alkyl halides. It is the order of the reactivity can be given. Sometimes the questions how we can expect it. Let us say I have given here CH3 twice CHBr, CH3 twice CHI, same way CH3 twice CHCl. This is secondary alkyl halide. It is also secondary. All of them are examples of secondary alkyl halides only. But only the point of difference is it is alkyl bromide, it is alkyl iodide, that is alkyl chloride. As you know that all of them secondary means all of them reacts at the same rate. But alkyl halides are different. Which alkyl halide is more reactive, children? Iodide. And hence if I label this as A, if I label this as B, if I label this as C. Iodide, bromide and chloride. So B is more reactive than A is more reactive than C. This is the order can be taken. Because this is going to be more reactive compared to this, and this one is more reactive compared to that. Such a way we can compare the reactivity of the alkyl halides. Hope that is clear for you, everyone, right? It's a in detailed data of SN1 mechanism required for the board examinations, which is actually required for the board examination data. Extension will be there, that we are not going to talk about it. Just I am going to talk about topic which is actually required for board part, your PU board or CBSE board. Next. Next we have SN2 mechanism. We have SN2 mechanism. SN2 mechanism, 2 means bimolecular. Bimolecular nucleophilic substitution. Bimolecular nucleophilic substitution. Generally, primary alkyl halides can undergo easily this mechanism. This is primary alkyl. Primary alkyl halides, 1 degree means primary, can undergo SN2 easily. How this actually mechanism can be proceeded? CH3 and I am taking primary alkyl halide, that is CH2Br, or CH3Br also can be taken. Let me elaborate this. CH, H, I am taking CH3Br, right? So Br is actually going from this side, this way Br is leaving. Parallelly OH minus should attack from the back side. Because here this mechanism is not like SN1 which can take place in 2 steps, it can occur in a single step only. What is happening over here? It is H, it is H, it is H. Carbon-bromine bond is becoming weak because you are going to break. That's why this bond is becoming weak. And it is going to form a new bond with OH. It is going to form a new bond with OH. So such a way, it is forming a transition state. Such a way, it is forming a transition state. Transition state is indicated as TS. In the transition state, carbon has how many bonds? 5 bonds. 1, 2, 3, 4, 5. But of course, these are partial bonds. Those are actually partial bonds. This is actually called as incoming nucleophile. Incoming nucleophile. Nucleophile, I am labeling it as Nu minus. Whereas this is Br minus, outgoing or leaving nucleophile. Leaving group, it is incoming group, right? Incoming group is attacking from the back side because Br is leaving parallelly or simultaneously from the front side. Both leaving group and attacking group are actually, works on same time. Leaving group leaves from the carbon and attacking group attacks on the carbon on the same time. And then what will happen? It will give you CH3OH. It's called primary alcohol. Because we have taken primary alkyl halide and nucleophile here it is Br, that Br is replaced by OH group. Such a way, what we got it? Primary alcohol. So in this case, rate is actually depending on K into concentration of alkyl halide as well as concentration of nucleophile. It's 1 and 1. So that's why which order kinetics it is? Second order kinetics. Here itself, it's alkyl halide, it's nucleophile. Rate is depending on both. 2 molecules are involved and hence it is said to be bimolecular reaction. Rate is depending on both concentrations. I mean alkyl halide concentration changes, rate also changes. Nucleophile concentration changes, rate also changes. For suppose if nucleophile concentration changes, rate remains same, then which mechanism it is? SN1. After changing nucleophile concentration, rate is changing, then that mechanism is SN2. Such a way we will be able to identify. And this SN1 and SN2. There itself you can see it was, in SN1 mechanism, there was a formation of carbocation intermediate. But here there is a formation of transition state. There is no formation of intermediate. Hope that is clear for you. That was means SN1 takes place in 2 steps. But here it is taking place in, it takes place in single step. It takes place in single step. Single step only, not 2 steps. Rest of the points are same, right? But here order of reactivity, once if you notice it, order of reactivity, this is a point of difference, order of reactivity. Primary alkyl halide is more reactive than secondary than tertiary. Why? It's all matter of steric endurance. OH is a nucleophile. It is attacking from the back side. If it is attacking from the back side in the sense, this carbon should not be surrounded by large groups. If it is surrounded by large groups, like let us say, if I have taken, tertiary alkyl halide like this, it's tertiary alkyl halide. OH wants to attack from the back side. Then this CH3, CH3, CH3. Bulky alkyl groups are there, no? They try to stop the attack of nucleophile. They try to stop the attack of nucleophile, creates steric endurance. And that is actually said to be steric endurance. Steric in the sense because of the bulkiness, these 3 alkyl groups will not allow the OH minus to attack at the carbon. In that case, the attack becomes highly difficult. So as number of alkyl groups increases, steric endurance also increases. Bulkiness increases, steric endurance increases, and then what happens to the reactivity? Decreases. Towards which reaction? SN2. That's the reason primary alkyl halides are more reactive towards SN2 mechanism compared to secondary and tertiary. Hope that is clear. So it's a general idea, basic idea of SN1 and SN2. Stereochemical aspects actually we are not discussing here. It's a board topic. For that, whatever it is required, it's discussed. Hope it is clear for you. Hope you understood. For more and more videos, and even for my encouragement also, if I would like to upload more and more videos, you have to like the video and share it, as well as subscribe to my channel for more and more second PUC as well as class 12 CBSE videos. And I'll meet up, okay, in the next video as soon as possible. Until then, take care. Bye. Signing off.